So we're on to 25, the structure for pantothenic acid. How many acidic hydrogens does it contain? So remember, an acidic hydrogen is going to be a hydrogen that's attached to a more electronegative atom. So you can get that polarity. So you'll have like partially positive hydrogen and partially negative oxygen. And so we can say there's 1, 2, 3 there. But there are other electronegatives besides. No, I guess there aren't other electronegative. Yeah. So basically, if it's attached to an oxygen, we know that it is a acidic hydrogen. So there are only 3 of those. So our answer is B. I was thinking the hydrogen attached to the nitrogen might be kind of acidic, but there must not be enough electronegativity difference for it to be acidic. So just always assume that it's the only time I can think of when it would be an acidic hydrogen is if the nitrogen has a positive charge, then it might be acidic. Other than that, just assume it's only the oxygens. A strong acid has such as HCl is added to a solution of acetic acid. What is the effect of the acetate concentration and the equilibrium? Oh, okay. So basically we're adding HCl. So that means we're adding a bunch of H3O plus, right? So we're increasing this concentration of H3O plus. So that's going to shift the equilibrium. If you have more of H3O plus, it'll shift it the opposite direction. So there's no change, is not right. The concentration, so this is acetate, right? That's not the acetate. This is the acetate. So the acetate concentration, if it's going left, is going down, right? Because we're decreasing both the acetate and the H3O plus. And the equilibrium is shifting to the left. So we'll go with 26. Excuse me. 26 is C. The acetate concentration is unchanged. Again, that's not right. Because we're changing the concentrations. Okay, give the following weak acid strong base titration answer. What? So 27, identify the equivalence point on the graph. So remember, the equivalence point is that point when, how do you want to find that? You find that by, I think you draw a line, and then you find the midway point between the lines of the two slopes, and that just so happens to be about D. The pKa for the acid is closest to, so remember at D, at 1/2 of the volume at the equivalence point, so the volume at the equivalence point is at about 50. So at about 25, the concentration of acid is equal to the concentration of base, I think. Let me go down to our... Yeah, I can't quite remember. But, so basically at half of the equivalence point, our pH is equal to our pKa. And sorry, I don't quite remember why, but I think it's in... I'm sure you can Google it or email me if you really want to know. I can figure it out quickly, just not right now. So at this pKa, the pH, at half the volume of the equivalence point, the pH is equal to the pKa. So that's about, what, a little under 5. Let's go with 4.75 maybe. So the textbook definition of a buffer is a solution that resists change in pH when acid or base is added to it. What region in the graph above fits that definition? So we have 0 to 10. We have 10 to about 40. We have 45 to 55. Well, that's like a huge jump, so we're going to get rid of 45 to 55. And there is a region that fits that description. Basically, in kind of that region from 10 to 40, it looks like the pH is changing a little bit, but not a whole lot. You can see from A to B there's more of a jump. So that's why we're going with B for the answer there. Calculate the Ka of a weak acid. We can use an ice table. Okay, so the initial concentration is 0.041 molars. And remember, if we're not given the base, conjugate base in H3O plus, we assume it's 0. So change, we don't know the change, so we're just going to call it X, right? And then we can say 0.041 minus X and X and X. And then we know the Ka is equal to the concentration of A minus times the concentration of H3O plus over 0.041 minus X is equal to over HA, concentration of HA. So we know that's X times X over 0.041 minus X. And we know the pH, so from the pH we can figure the concentration of H3O plus is equal to 10 to the negative 3.28, right? So which is equal to X, right? Because that's basically how we defined X here. So we can say 10 to the negative 3.28 squared divided by 0.041 minus 10 to the negative 3.28. And for that answer, you will get C. Which of the following half reactions is balanced? So remember, a balanced reaction, first thing we'll want to check is the number of the atoms. So we have 2Cl, 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 1Cl, 2Cl. That's not going to work. 2Cl, 2Cl. Okay. Then let's check oxygen. 1, 2 oxygens. 1, 2 here. 1, 2, 3 oxygens. 3 oxygens. 1, 2, 3, 4 oxygens. 4 oxygens. 1, 2, 3, 4. 1, 2, 3, 4. And then hydrogens. 1, 2. 1, 2, 3. That's not going to work. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then we check charges last. So this has 2 times negative 1 is 2. 4 times negative 1 plus 2. So that's what? 2 versus 6 negative charges. That's not going to work. And we have 2, 3, 4 versus 4 here. And that works. So our answer is D. 32, identify the oxidizing agent. So oil rig is how I remember oxidation is lose, reduction is gain. And remember, the oxidizing agent is the one that's reduced. So the one that's gaining electrons, let's see, the Fe goes from negative 6, and that total will be negative 3 is going to be our, we can do that cross thing I was talking about. So, right, our total charge on the oxygen is negative 6, negative 2 times 3. So negative 6 is the total charge divided by 2 is negative 3. So it goes from negative 3 to 0. And aluminum goes from 0 to negative 3. So it looks like the aluminum is gaining electrons and being reduced. The oxidizing agent Oxidation is lose. Is my key right? It says that A is the answer. Well, aluminum is going from 0 to a -3 and being reduced. The oxidizing agent. Am I crazy? Oxidation. Well, this is being oxidized, right? Because it goes from -3 to 0. And to go from -3, it has to lose 3 electrons. Let's go back to our old exams. I'm gonna double check the key. Maybe I wrote it down wrong. Let's see, and we were concerned with, what are we concerned with? Number 32. 32, well, it says the answer is A. Welp. Oh. The oxidizing agent. Well, email me if you come across why. Email me when you figure it out. And sorry, I don't have the answer. And if you email me, I will figure out the answer. But yeah, email me if you have questions about it, and I will figure out the answer. And if you do know what the issue is, then good job. I'm gonna go back to markup. Okay, so sorry about that. Yeah, let me know if you have questions about that, and I will email someone, or maybe I'll look at it later and post a new video, but yeah, sorry about that. Okay, number 35, how many covalent bonds does carbon form? So remember, carbon forms 4 covalent bonds. That's just something I guess you need to know if you kind of draw out a carbon, like methane. You can see it always forms 4 bonds. Or you could look at your next thing and see, oh, carbon has 1, 2, 3 hydrogens plus 1 bond to another carbon, 4 bonds. Which of the following species are structural isomers of C6H14? So 6 carbons, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. That's not a structural isomer. 1, 2, 3, 4, 5, 6. Okay. And it looks like 1, 2, 3, 4, 5, 6. This actually has 1, 2, 3, 4, 5, 6, 7 as well. Now none of these have double bonds, and we have the right number of hydrogens for all of these, or all of these are going to have the same number of hydrogens. Basically these two are going to have the same number of hydrogens because there are no double bonds. So we'll go with 2 and 4. And I'm stopping here. I'll pick it up next video.